Alright guys, this is what my husband was building today, which I said that I would do a second video to show you exactly what he is doing. So I want him to explain to us now what is really going on here. Mr. Forrest?
Yes, we are here in the madness shop here, mad scientist again. Yeah. Well, here we are again with a battery bank setup. And basically I use this to power the house, 5000 watt inverter. And this is another UPC. This is a UPC. Actually it's a UPS, uninterruptible power supply. And this is what controls my camera and my internet if the light gone. Okay. This is a washing machine turbo motor.
Yes.
Right? It is not brushless. But it's just a idea that came to my mind and I decided I'm gonna try it. Now this is a car alternator. Right? I know the car alternator produces 12 volt up to 14 point something volt, right? 14 max. So basically the idea just came to me to connect up a motor that can spin it fast enough to produce that amount of current that can charge at this battery bank. Now this can work 2 ways. I can plug it straight to the wall,
yes,
and it can be used as a standalone charger to charge up the bank with the utility. But right now I am trying something different. Right now I am trying to see if I can create a current loop, which I think I may or may not have. So right now what I do, I connect the motor to my inverter. The inverter is powered by my battery bank, right? And if you try this plug is what is plugged to the inverter. Yes, the house is hooked up to it as well. Right, but right now it's not under any load except for the motor that is drawing current from this inverter. So the inverter is powering the motor is driving this alternator, and the alternator in turn charging back the battery, right? So right now the multimeter reads 12.20. Let's see if I can show you guys something. So if I'm going to loosen this, I'm going to loosen up this belt a bit, and you're going to see once the alternator, this is what you would normally see inside of your car, right?
yes,
This bulb, or in your dashboard, and this will tell you whether or not your battery is charging. Right now it is off, so it's therefore telling me that it is charging. The system is charging. So I'm going to slacken the belt a bit, and you will see that this is not spinning fast enough to create the necessary magnetic field inside of this alternator to charge your back. So look, listen to it, listen to it.
Oh wow.
There.
Wow.
So right now this bulb is telling me indeed that the battery is not charging, and if you look at my multimeter, the current dropped from 12 to 11.9, right?
Yes.
Alright, so I'm going to add back the load, add back tension to the belt,
Yes.
and you will see this light go off.
Okay. Oh, amazing.
And you can hear the motor oil drop, right?
Yes.
Alright, I'm going to show it. So see the magnetic field is creating more so you see part I make the belt,
Yes.
is the more force it gets, and the voltage goes up. So you see now it's at 12.2 volts.
Yes.
Alright, I'm going to do something else to show you that this thing is serious. This is a battery clamp. You notice that the value in the multimeter has changed because I've removed the negative clamp that is connected to the alternator. So now look, you're going to hear the motor drop, if you can hear it on the camera, when I connect back the ground terminal.
Oh wow.
So you see the difference? Now, normally in a car situation, once you want to test your alternator to find out whether or not it is charging your battery indeed, you would remove one of the terminals. And that would tell you whether or not your alternator is charging. Right? So this is telling me that the alternator is charging and the light hasn't come back on. Right? So listen, when I attach it back to the battery, you hear it drop. You see that spark? See the spark? Yes? Alright, look here now. I'm going to remove both terminals. See, so without the load, without it charging the batteries, right? And if you look right here, I have the two terminal in my hand. Yes, motor is spinning. That is what is driving the motor. The inverter is what is driving the motor, right? So, so I'm going to put a bulb on this. Just the alternator alone without any battery. Remember now, the battery is powering the inverter. The inverter is powering this motor, and this motor is what is driving the alternator. Alright? So now I'm going to connect this negatively to a bulb, a car bulb, 12 volts. If I can get it on there. Yeah, will it work? Alright. There we go. Now I'm going to, this is just the alternator, so I'm going to show you now that this bulb is going to light up when I apply the positive side to this bulb.
Okay.
See that?
Wow.
And you hear the motor how it drop.
Yeah.
You can hear the sound in the motor as it gone down. See, look. This is low beam on the car. Right? And this will be high beam.
Wow.
See that? So indeed, I am getting voltage out of these clamps. I'm going to use the multimeter right now and see if I can get a reading again, show you. So this is just a little experiment I'm trying out, and I believe that, you know, it should work. Now if you look at my multimeter, this is the negative pole. Multimeter, these clamps are a bit rusty, so bear with me a bit. If you look at the multimeter, test meter, come on. Clamp is giving me some trouble. Right, so if you look at the multimeter, you'll see that it says 0. I'm going to drop. This is just the connection from the alternator. I'm going to put on it on the ground terminal now. And if you look at the multimeter, you see it reading 14.46 volts. Right? So that is optimum to charge the battery. Now, if I plug out this out the inverter, I'm going to plug it out of the inverter now. Right? Or better yet, I'm going to even shut the whole inverter. Alright, you can see that the system is going down, and of course the dummy light that would normally show up in your dashboard light up briefly. Alright, so now I'm plugging it out of the inverter. Yes, and you're going to follow me now. I'm going to plug this straight to the wall. So this is the loop system running from an inverter to this washing machine motor and the motor driving this alternator. This would work like in the car. So this represent the car engine, only that I'm not using gasoline, I'm using current to create a loop, right? So this now is driving this alternator, and of course the alternator makes its own current from magnetic field, right, within the alternator. So when you find out now, because the field is excited based on the speed that this can deliver to this, it gives you the voltage out now. And that is what charges the battery. Now I am still in the test and the trial and error phase, still with this as I go along. So now, but let's say for example I had this battery bank, right? And I wanted to charge up this battery bank, but I don't have anything to charge. I don't have no solar panel. I don't have nothing to charge it, but I want to charge up the battery bank so that in the event light goes, I would have, some current without having to run it like a generator or so from an inverter systems. I could use this as a charger just to charge the system from the outlet. So now I'm going to plug this into the back of this, because this is connected to this plug down here. Look. So I'm going to plug in that system up there, because right now that system isn't on the grid. I'm going to plug it into the grid now, and you see the light up.
Okay.
Alright, so say this is the grid. I'm going to plug it out back. Now the thing about this UPS is I've converted into a different system. Normally they have some small batteries in here, but I take out that and I rewire it in a different way to run off all of these batteries, right? This is a 24-volt system. This is a 12-volt system, right? So basically, this normally would charge the battery that is in there at 27 volts, because it's a 24-volt system. But I take out that battery. That battery don't last any time. With this bank, I can it powers my camera for a few days and my internet if the light goes. Just this alone. This now is a 5,000 system, 5,000 watt inverter system. This can power my entire house, my light, my fridge, washing machine, you name it. Just like how you have a generator. Yes. However, I'm still stacking on my bank, right? These are car batteries and old batteries that I got, and if they were even brand new it would be even better, but these are reconditioned batteries that are reconditioned and decided to use for this project. Now, God. So now, so as I was saying to you, normally this is plugged to the wall, and in the event that the light goes, it automatically switch over to DC power and convert that DC power into AC power to continue running your equipment, such as your computers, delicate stuff like that, so that you can have a little time to shut down and so forth. However, I don't have to do that because this is on a bigger bank system. So normally now it would be plugged in, and then this would charge back the bank, right? This would charge back this bank, right? So now I'm going to plug it in the wall, and you should hear a click. If you don't, then I guess you don't. There's the light. There was the click. And now this would be charging. This would be charging back the 24 volt system. Now, if you notice, right, I only have 3 batteries here. Each of them is 12 volts, right? The 24 volt system is connected in parallel, and I have a jump off from the 24 volt and get the 12 volt to power this, right? So it's 3 batteries. So at this point I would get 24 volts, right? But because the system is charging at the moment, from this may get 25, it's going to go up to around 27 volt, right? Yeah, 25. See, going up to 25. Yeah, it's going to climb up to around 27 volt, right? Because I was kind of just playing around with it. Now this on this side, on this single battery now, which is at 12 volt, it's connected on this bank as well, and there you can see it's measuring 12.59 volts, right? So right now this battery bank is charging this and trickle charging this in the same breath. So it's all charging, right? So now I am back to the alternator. Let's say, for example, some random reason the charging mechanism in this device stopped charging. I could use this as a standalone unit to charge the bank, or I could use it to help boost that system to charge the battery bank even faster, right? Now inside of this there's a built-in regulator inside of alternators. That is why when you're driving down the road your car don't explode, because your battery don't blow up, because there's a built-in regulator that regulates the current going to the battery. So once it reach the desired voltage capacity that the battery normal stores at, it sends it detects that and stop charging the battery unless you add load to it, start using current from the battery, it start charging again.
Yeah.
Now, so now if I wanted to charge this from the wall, all I would have to do is, here's the plug. I could plug it on the current side of this, which is the wall side of this device, and the motor would come up, right? So this is going to spin up the motor. All right. Now, the reason why you don't see this light come on, right, is because the system is already pre-charged. I configure it for it to come on, right, pre-charged. If I slacken this belt, it loses tension. Wait for it. Wait for it. Okay, let me get some current running through. Have it positive. Alright, there we go. We have the bulb, right? Now, let me just disconnect this out a little bit because the belt, I slapped it too much and the belt jump off. So I put it on back the belt. Alright, there we go. So we connect back the battery to the battery so that we can have current flowing through the system, right? This light turns on because what happens is that when you apply 12 volt to the alternator, what happens is that the rectifier inside that sends ground terminal to the ground terminal inside the regulator. So that's why that come on. So once the field is excited, based on how fast this is spinning, the light goes out because it turns off that circuit to send out the current to charge the bank. So now I'm going to plug it back into the wall now, right? Let me plug it back into the battery side of this, but the wall side of it, right? There we go. Start him up. So that is running from the wall, the AC power. I'm going to tighten the belt now. Alright, see that?
Light came
See
on.
the light chip out? Now it is charging this back, it's charging the whole system, right? So let me see how much volts is there. And if you notice, the system is running. The motor sounds like it under load because it is indeed charging, right? See that? 12.54. Turn on the light. 12.54.
Nice.
Right? Now, if I go some more, you hear it under load because it's charging the battery. 12.8, 12.9, 4, 5, 6, 7, 8, 13 volt and still climbing, right? So that would be from the wall. And normally in your car, that's where your engine would get the engine idling or at speed to charge your battery in your car.
Yeah.
Right? 13, and it's still climbing. It goes right up to 14 volts. So, you know what I'm saying? This is power. So if I wanted to use a wall, current from the wall to charge back the system, to have the charge up, I could run it this way and it charge the system up and maintain the charge. And then in the event that light goes, it would continue running from the battery bank system. So now I have been this whole time playing around my inverter, you know, to see what if I could get this thing into a loop. So if I could get this, because this converts this 12 volt system, 12 volt, this is a 24 volt, the convert to AC current to run the other, my camera system and Wi-Fi, and this now is what power your house. So I'm saying, well, if I could get this to continue in a loop, surely it should work, right? So that's where I'm at. So now what I did, I plug it out from the wall, just like that, right? So the battery light come on now because it's there telling me that the system is charged. The alternator has current flowing through it, but it's that's a dummy light in the car. And then I said I would plug it into my inverter, right? And then I would turn on my inverter to see whether or not if I could create a loop. So this battery bank would give current to this. So this is my power source. The battery bank is the power source, and then the 12 volt will be converted to 110 volt, right? Now the 110 volt that is coming out of this is what would be driving this motor. So once me get this motor to spin to a certain velocity, then this would indeed charge back the battery bank, because indeed this is how it would work in a car. If you're driving and you're using the AC and whatever, the battery is not dying. This is what is charging back the batteries in the car, right? Now the difference is to the power from the car wouldn't be the battery, you know. The power in the car situation would be the petrol that is in the tank. So the engine. So the engine takes its power source from the gasoline and converts that into mechanical energy. And then this now from the battery excites the alternator, and the alternator then in return charge back the battery, and that goes around in a loop. But in order for that to create that loop, it's not really a loop per se, because it is using the gasoline as its source of energy to create that power source, which is why you find out that on some YouTube videos they use like a lawnmower engine or something like that in order to drive the alternator. Now the power source for that motor to drive the lawnmower engine to drive this alternator would be the gasoline. But I don't want to use the gasoline. It's kind of very, very loud using one of those engines, right? It's an engine. So I just say to myself, then I wonder if I could get a motor that could spin this fast enough to give me the same amount of torque that the lawnmower would, right? So I found this old washing machine motor, and I decided that I'm going to try it. And it just turned out that this motor it's not a brushless motor, so over time these brushes would have to change because it's rubbing on the surface of the stator, right? So I said, all right, I want to see if I could create a loop, a current loop. Though I believe that over time it may or may not drain the battery. I still have to do some more research on that. But I think I may somewhat get it to work somewhat, because alright, so I'm gonna plug it in at the inverter, turn on the inverter, right? Inverter going to come up, start spin up, dummy light turn off, right? And I'm getting 12.95678 13 volt, 13.1, and still climbing, right? And my inverter indicator light, right? If I can get it to focus. Yeah, something like that. See? So it's telling me that it's receiving a good amount of current, right? And so right now it is flowing in a loop and my battery is charging. So this is doing exactly what I just said, that it converts this current 12 volt to 120, and then that drives the motor, this drives the alternator, and then it's going around like that in a circle, right? So I'm going to plug out this wall light, because indeed this will be sending a little bit of charge to the system as well. So let me plug it out. So this is plugged out, and I'm getting 12.0. It is dropping. Alright. So this is where I'm at now, playing with it to see how I can increase you hear it squeaking because it's under load. That's 0.8. Yeah, so I get it at 12.8, 12.84. Yes. And right now it seems to be steady right there. So this so right now this 12.85 is climbing. So right now as we speak, this system is running in a loop. Right? This system is running in a loop. So you know, that I will just show you guys, you know, what I've been doing. Yeah, so as I said, this battery bank converts. This is 12 volt. Well, it's really one battery running this system off, which is this 12 volt, but it still gets some aid from this because it's still connected to that. Although this system is set up for a 24 volt system and I top off of that with this battery. So it convert that all of that to 120, right? Right, and it then this is plugged into this, right? See, that's still climbing 12.89, and this, and the reason why it's squeaking is because it's under load and it's charging the battery, right? So that drive that, and that drive that, and that send back current to that. Yes. So this is basically how this system is working, right? I still want to try and see how well I can perfect this system still. Ideally, I want to get a motor, because right now this motor, yes, it's a washing machine motor. I don't know if you guys have seen the one where I turn on one of these washing machine motors into a circulator from a turtle pond, but I find these little motors to be very useful. I don't throw them away. You know, I take them and I try to build something out of them, you know. So yes, this motor is a turbo motor because it works on one of them washing machine, front load washing machine, and I just basically convert it, you know, on this board thing to try out this project that has been long in my head for a while now. And right now, as that is, this motor is a brush motor, right? I don't know if you can see it sparking. Yeah, it's a brush motor. I think it would have been better if it was a brushless motor. You wouldn't have to worry about the carbon, but it's a brush motor, and that's what I had to work with at the time of trying to execute what was in my head. So there you have it. Yes, indeed. You hear it from the mad boy himself. Yes, quite so. Yes.
Alright guys, until next time, please like, subscribe, and share. Bye. Say bye, Joe.
Yeah, man. Until we meet again.